Air is what we breathe and what is all around us. We feel air, but we can't see it. Air is a mixture of gases. A gas is matter that does not have a fixed shape or volume, which means it can move around freely and take up any given space. When we breathe, we take in oxygen and breathe out carbon dioxide. As plants go through the process of photosynthesis, they use carbon dioxide from the air and release oxygen. This cyclical relationship between plants and animals helps maintain life on Earth. Many people think air is only made up of oxygen and carbon dioxide, but it is actually made up of many other gases too, in addition to water vapor and some contaminants. Nitrogen is the most abundant gas present in air. In order for plants and animals to use nitrogen, it must be converted into nitrite, nitrate, or ammonium. Nitrogen-fixing bacteria do this by absorbing nitrogen from the air, converting it, and depositing it into the soil. Plants then absorb the converted nitrogen and use it as a nutrient to grow. When people and animals eat nitrogen-rich plants, it helps to develop strong bones and muscles. Other gases found in the atmosphere are argon, hydrogen, neon, helium, krypton, ozone, and xenon. Do you think all these gases are present in the same proportion? Proportion is a comparison of two or more numbers that each represent the parts of a whole. The answer is no. As mentioned, nitrogen is the most abundant gas in air. It actually makes up approximately 78% of the air around us. The second most abundant gas is oxygen at 21%. The third most abundant gas is argon at 0.9%. This means argon is a little less than 1% or 1 out of 100 parts. The fourth most abundant gas is carbon dioxide, the gas we breathe out and the one plants take in, at only 0.033%. The remaining gases of hydrogen, neon, helium, krypton, ozone, and xenon make up the rest of 0.067% combined. We know percents are equivalent to a unit fraction of 1/100th because percent literally means per hundred. But how can we convert decimal percents to fractions? It's important to first understand that a decimal percent represents less than 1%. So the way 20% would represent 20 hundredths and 5% would represent 5 hundredths, 0.75% would represent 0.75 hundredths. If we were to use a hundredths grid where each percent represents 1 square, 0.75% or 0.75 hundredths would represent less than 1 square. This 1 square would be divided by 100 smaller pieces and 75 would be colored in. However, 0.75 is only representing a part of the specific square we are zoomed into. If we zoom out to understand 0.75 hundredths to the entire whole, we can figure out how much this tiny section takes up in the entire whole of 100 squares by further reducing it and removing the decimal in the numerator. How do we further reduce 0.75 hundredths to remove the decimal and write it in fraction form that includes a whole number in the numerator and denominator? We would have to divide each square in the hundredths grid into 100 pieces. This would give a total of 10,000 squares to the original hundredths grid. That means 0.75% or 0.75 hundredths equals 75 10,000ths. Using the standard algorithm, it would be the same as taking 0.75 hundredths and decomposing it to find an equivalent fraction with a denominator of 10,000. To do this, we would multiply the numerator and denominator by 100. Doing that will give you 75 10,000ths. Now, do you think the proportion of gases in our air matters? Can there be different amounts of gases in our air and still have a planet that can sustain life? Oxygen, for example, is a highly reactive gas. If the amount of oxygen in the air increased to 35% or more, everything around us would erupt in flames. Have you ever noticed that the flame from a candle can turn off if you place a cup over it? Or placing a blanket or towel over a small fire can also turn it off? This happens because the oxygen supply is completely cut off. Fire reacts with oxygen, so if the oxygen supply is cut off, then the flame turns off too. Let's take another gas as an example. What if there was an increase in carbon dioxide? Well, carbon dioxide helps maintain the temperature of the planet. When the sun's rays reach Earth's surface, the energy is converted into heat, and then much of it escapes into space. Carbon dioxide in the atmosphere traps some of that radiant energy so that it can warm the surface of Earth. If the amount of carbon dioxide increased, the temperature of the planet would rise. Even a small increase in the Earth's temperature could have dramatic impacts on the Earth's surface, and we are already seeing that through evidence of climate change. What actions alter the change in gas proportions in our air? Cutting down masses of plant species such as trees by clearing out forests for other uses releases the carbon dioxide they had stored up. And since they absorb carbon dioxide, destroying them limits nature's ability to keep emissions out of the air. Burning fossil fuels to produce electricity and heat also produces gases like carbon dioxide that enter the air and blanket our atmosphere, trapping the sun's heat in our planet. Maintaining the right proportions of gases in our air is very important to sustaining life on Earth. It is also very important that we understand the impact that our activities have on the balance of gases in our air. All the different ways that our air is polluted can seriously impact the delicate balance that allows life to exist on Earth.